Hi, I'm going to be analyzing a standard from IB Physics, which is a grade 11 and grade 12 curriculum. The IB standards are presented as topics in the subject guide, so I have the physics guide here. These topics are a little bit easier to dissect than the NGSS standards because the content and skills are presented in list form, as you can see in this format explanation. The understandings are the content, the nouns you would look for in an NGSS standard, and the application and skills are what students need to do to meet the standards. The other stuff I will talk about a little bit more when I look at my subtopic or my standard. So I am going to be looking at a subtopic 5.4, which is under topic 5, electricity and magnetism. Each topic has a suggested number of classroom hours, and for this topic, that is 15 hours. There are 4 subtopics here, but I would plan out 3 units, and those would be electricity, electric fields, and magnetic fields. So each would have about 5 hours teaching, a little bit more than 5 lessons, maybe use 7, but that's still okay. So let's go to mine. 5.4 is magnetic effects of electric currents. The content, what students need to know, is understanding. So that is magnetic fields and magnetic force in this case. What do students need to do? That's applications and skills. For this subtopic, they will need to be determining the direction of force on a charge moving in a magnetic field, determining the direction of the force on a current-carrying conductor in a magnetic field, sketching and interpreting magnetic field patterns, determining the direction of the magnetic field based on current direction, and solving problems involving magnetic forces, fields, current, and charges. So each of these things might be one lesson, but due to the complexity of some of the problems, they might actually take a little bit longer than one lesson. So that's why this is like 5 teaching hours, which would be more than 5 lessons. But like I said, that's okay. This topic is one of the more difficult topics in IB Physics because it requires relatively more complex math, and the physics here is really hard to visualize because it goes against intuition at first. Like, the magnetic field tends to produce forces that are in a different direction from the field itself. But this really is appropriate for this level because of the way it's treated. You can see here in guidance, magnetic field patterns will be restricted to long, straight conductors, solenoids, and bar magnets. We will study only special cases where the math actually becomes easy and manageable. So students can do this. It is manageable for grade 11 and grade 12. Now let's talk about the other stuff in this standard. In IB, they like to focus on well-roundedness and global-mindedness and connections outside of the subject. And that's what these other things are. They can be taken as suggestions that may be used, but you can also come up with your own ideas. It's not necessary to build these into every lesson, but you should choose some of these for your big ideas in teaching. One thing that is incredibly fascinating is how light, electricity, and magnetism are actually the same thing. Even though they seem so distinct, that's not true, and students will be able to see some aspects of this link here. Another big idea. It's interesting how the unit of current measurement, it's the ampere, it's defined in terms of the force between 2 wires, and not per unit time. And actually, the ampere is considered to be a fundamental unit in physics, but charge is not. One activity is to have students use this online simulator of magnetic fields to visualize the field around a current and see the effect on charged particles. They will change the parameters to observe how the size of the loop, the number of turns, and the current affect the field and the paths of particles. They will do this using a worksheet guide with a translator handy and with a partner or a small group, along with maybe a thinking routine such as think, pair, share to explain what is going on. They would be allowed to discuss this in their native language too. That is okay with me. This simulation has a lot of things to explore. This will allow curious students to go beyond the content of this topic and observe more complex cases. This second activity would be more of an introduction to this topic. Students will use the magnetometer in their phones to measure the magnetic field around objects in the room. They will sketch graphs of how the field changes over distance, and we will discuss which objects had magnetic fields and why. If students wanted to go further with this activity, they could export the measurements in an Excel file and analyze the data with a computer. It is beyond the content to study how the magnetic field drops off with distance, but some students would be able to understand this and they may be interested. Finally, to assess mastery of this topic, the students will work in homogeneous groups on a project, which I will adapt from this Canadian PBL site. The project asks students to consider safety issues with magnetic fields from power lines. This will require them to use the formulas from the unit and apply them to a real-life situation. These groups will be homogeneous so that the instructions can be differentiated and scaffolded to different degrees depending on physics ability and on language ability. For example, I may reduce the number of power lines and have a simpler geometry for students who've been struggling. I will also let them translate this project. In summary, I have unpacked topic 5.4, magnetic effect on current. I'll sum up this topic in as few words as possible. Magnetic fields are created by and have an effect on moving charges. Students should understand this and be able to apply the relevant formulas. I try to invoke 21st century skills in each assessment, which are very often collaborative because I have many students with weak English and they need peer support.